Okay. So basically, the Taylor series, Euler series, Runge-Kutta second order, fourth order are being used to find out the solution of ordinary differential equation. So here is the problem statement. You can find this kind of a problem statement generally we have in examination. Not exactly. This is only the sample. Here we are. I request all of you students, don't expect the same numerical will be there in same examination. You are here to understand the methods. Those students who have missed this technique, for them, I'm just taking a revision of that method, right? Okay. Let's try to understand here how to solve this numerical. A solve dy by dx is equal to 3x plus y square using Taylor series method. When x is equal to 0, y is equal to 1, find the value of y at x is equal to 0.1. Just a minute, students. Yeah, I was talking about we have to find the solution of dy by dx 3x plus y square using Taylor series method. When x is equal to 0, y is given 1. Find the value of y at x is equal to 0.1. Now, if you are looking at this formula, student, the formula generally, what we are having, in both way you can say a function f of x or y0. Both are nothing but same. F dash x is nothing but y dash into h. So if I do write the formula here, I would like to write that formula in known terms like y is equal to, that we have to find out, is equal to y0 plus y dash h plus y double dash upon 2 factorial h square plus y triple dash upon 3 factorial h cube plus y raised to 4, means what? 4 differentiation upon 4 factorial h raised to 4. Generally, when we are using in a Taylor series, we are using the terms of Taylor series up to 4th order, right? So otherwise, it becomes very difficult for anyone to find out the higher order derivatives. Is that it, students? Any doubt, any question? You can stop me with that. Fine. So this is the formula that we are using. Now, if this is the formula, what exactly we have to write? See, we have to find out y at x is equal to 0. So first of all, we'll write down what is given in the problem statement. So given data. So in a given data, you can see that dy by dx is equal to 3x plus y square is given. That means what? F of x is given, right? F of x is given. So we can write f of xy is equal to, or f of x, you can say that, not xy, f of x is given as 3x plus y square. So this is what your function, right? We'll write this as equation 1. But before that, we'll just convert f of x. There are two types of formulas, right? As I given right now. You can write either in terms of f of x or in terms of y. So it is better to convert this f of x in terms of y. So I'm going to convert that. That is nothing but y is equal to, or we can say that y dash is equal to, because it's a dy by dx, y dash is equal to 3x plus y square. Okay. Let's say that this is the equation number 1. What else we have here? Then we got when x is equal to 0, y is given. That means our initial values are given. So why this is given? To find out y dash value, right? Ultimate our aim is like to find out y dash value, y double dash value, y triple dash, and y raised to 4. These values we should know. Otherwise, y0, that it means at x is equal to 0, the y value is already given. So we can use this as an y0 value, right? So this is the y0 value. Then what is the next y dash value? Y dash value is nothing but the function which is already given in the problem statement, right? Excuse me. The same equation can be written in some cases y dash is equal to 3x plus y square. Don't get confused because y dash itself represents dy by dx. It's a first derivative function, right? So after getting y0 from the problem statement, can you see that in the problem statement, this value is already given? Then you have to find out y at x is equal to 0.1. Now to find out y value at a 0.1, we required y dash, y double dash, y triple dash, y raised to 4. And apart from this one, we should also have the value of h. Okay, so by knowing the value of h only, we can find out then the entire, using a series, we can find out the value. Now try to understand, students, h is not given in the problem statement, but it is indirectly given. How? We have a value like x is equal to 0, and we are being asked to find out at x is equal to 0.1, right? And h is not given, problem statement. H is not given. So we can say that h is nothing but considering the one step between them, right? So 0.1, the difference between these two values is nothing but h, right? Difference between these two values is nothing but h. So h in our case, it is equal to 0.1, right? And here we are using one step only, one step value. Basically, the Taylor series is only one step solution. Any question by the time, students? Hope so. What is given in the problem set we discuss. Any questions? Hello?
No, sir.
Oh.
No, sir.
Okay. अभी क्या करना है मुझे? We have to find out all these values. Y0 we got. ये समझ में आ रहा है ना? ये वैल्यू मुझे मिल गई सीरीज में से. So y dash we have to find out. So to find y dash, we already have an equation. Y dash is equal to 3x plus y square. Yes. So we also have the values of x and the y. So we can substitute in this equation. So we'll get the y dash. Y dash is equal to 3 into 0 plus 1 square. So that value is nothing but 1. So we got on y dash. Right? We got y dash. So this is our first solution. So after finding out y dash, we have to find out y double dash. So second, we have to find out y double dash. So how to find this y double dash? Yes, students, how to find y double dash?
Take derivative of first y dash.
You have to take the derivative of equation number 1. So we can write here differentiating equation 1. Then what we are getting? Y double dash. So differentiate this equation. What you are getting here? 3 plus 2y y dash. Okay, so let us say that this is the equation number 2. Now, what values we are having? We have x is equal to 0. At x is equal to 0, y is equal to 1. Also, y dash is equal to 1. All these three terms we got here. So we'll substitute in equation number 2. So what we are getting? Y double dash. Y double dash is equal to 3 plus 2 into 1 into 1. So that is nothing but 5, if I'm not wrong. Okay. Similarly, now 1 by 1, up to 4 terms, okay, of Taylor series, you have to find out all these values. Now third what we want? Y triple dash. So what we are doing? Differentiating equation number 2, right? Differentiating equation number 2. So what we are getting? Y triple dash. Y triple dash. So can you help me out? Just tell me what's the value. So derivative of this 3 will be 0 plus, here it is the product. Tell me. 2y into y double dash
double
plus
plus 2
2y dash y dash. Correct? So it's a very important. See, here for the discussion, we have taken very simple equation f of x. Right? Y dash is very simple, but you should know how to differentiate if it is trigonometric functions or the exponential function. You should know how to find the derivative up to fourth term. Okay, fourth order equation you have to get. Fine. Simplifying this, 2y y double dash plus 2y dash square. Can we write this one? 2y dash square. So let's substitute now values. What we are having? We have x is equal to 0, y is equal to 1, y dash is equal to 1, and y double dash is equal to 5. Let us substitute all these values in y triple dash. So after substituting, we will get y triple dash is equal to, can we have calculation here? 2 into 1 into
5
5 plus 2 into
into
1 square. Tell me this value.
7.
Please do have
12.
calculation.
12.
Is it 12? Okay. Y triple dash is 12. Cross verify students. Then what's left with us? Fourth term. That is now differentiating equation. We are written from somewhere equation. This is equation number 3. We have to write like equation 3. So what we are getting? 4 times. Okay. So can you help me out to write that value? So what we are doing? Dy by dx. Dy by dx is equal to differentiating what? 2y y double dash plus 2 y dash square. Tell me, derivative of this. We are differentiating 4 times. 2y into y triple dash plus 2y double dash y dash plus what's next? 4y dash
y double dash.
y double dash. Okay. Simplify this. 2y y triple dash plus, now these terms are similar. So can we write 6 y dash y double dash? Yes. Now we got all the terms. Now let us substitute all the values. What we are having? X is equal to 0, y is equal to 1, y dash is equal to 1, y double dash, if I'm not wrong, 5, y triple dash is equal to 12. So substitute all these values here. So you'll get fourth term,
54.
54, right? We got a 54. So now see where we have started in Taylor series. This is the Taylor series. Can you remember this equation? This is the Taylor series, right? It has a higher order terms. But when you are applying for examinations, we are restricting ourselves up to fourth order. Okay, because Fifth order, higher order terms, it becomes very difficult for us because the equation is very simple. So we can find out higher order derivative also. But if the equation, if it is complicated, then it becomes very difficult for anyone to find out the higher order differentiation or derivatives. So we got y dash, y double dash, y triple dash, y raised to 4. And also we got h value, right? So let us substitute all these values in this series and let us find y at x is equal to 0.1. Since it's a one-step method only, right? Okay, rewrite the formula. Let's just help me out to write the formula. Like y at x is equal to 0.1 is equal to y0 plus y dash h plus y double dash upon 2 factorial h square plus y triple dash upon 3 factorial h cube plus y 4 times upon 4 factorial into h raised to 4. Isn't it the formula? Yes, students? So let us substitute all the values. What's the value of y0? 1. Y dash 1 into h is 0.1 plus, generally h value is given, right? Here it is not given, but the initial value is known to us and the final value is known to us. So we can find the difference between them, right? And that difference is nothing but h for the Taylor series, if it is not given. Y double dash, is it 1? What's the value of y double dash? Yes,
5.
5. The value is 5. So 5 upon 2 factorial. What's the 2 factorial? 2 into 1, right? Into 0.1 square plus y triple dash. Y triple dash is 12 upon 3 into 2 into 1 into 0.1 cube plus 54 over 4 factorial. 4 into 3 into 2 into 1 into 0.1 raised to 4. So if you simplify this, you will get the value of y at 0.1. Can anyone please?
1.127.
1.127. So this is the value of y at x is equal to 0.1. So you can write your answer here. Answer. Always highlight your answers. No? Answer. At x is equal to 0.1, the value of y is equal to 1.127. Just highlight this. This is your answer. Now tell me, students, any question, any doubt in Taylor series?
No, sir.
सर
Mm-hmm.
सर एच ची व्हॅल्यू कशी काढली एकदा सांगाल का परत?
Yes, yes. See, as I told you, generally h is what? It's a strip size. Okay. So h formula is nothing but xn minus x0 upon number of strips. Since Taylor series is one step formula, मैं क्या मतलब इसको क्या बोला मैंने? ये क्या है? एक स्टेप में आपको आंसर मिल जाता है टेलर सीरीज से. So it's a one step method. So generally n is equal to 1. If n is equal to 1, so h becomes xn minus x0. So xn is nothing but the value जहां पे हमें निकालना है. That becomes xn and this is what x0. Right? So if I'm applying the same, so what I'm getting, h is equal to xn minus x0. So what is xn? 0.1 minus 0 is equal to like this. If it is not given, generally it is given in the problem statement, h is equal to 0.1 or 0. Okay, it is very, you can easily understand, students. If I'm writing h is equal to 0.2, does it make any sense? Hello? Does it make any sense here? See, range, initial value is 0, and we have to find out at 0.1. So how can I divide 0 and 0.1 into 0.2? So it does not make any sense for a Taylor series. So h you can take it as 0.1. So initial value and the final difference between these two. Is there any difficulty, students, now?
No, sir.
No, sir.
No, sir.